This is a short video to introduce you to the ideas of domain and range, what they are, and how to express them. Basically, in any given question, the domain is all of the things that X can be, or whatever your input is in that question. And the range is what are all the things that Y can possibly be, or whatever the output is in that question. Let's just start with the quadratic function here. F of X equals 2X squared minus 6X plus 3. We have a few ways to evaluate this now, but since it's in standard form, the quickest way to find the vertex that we know now is using X equals negative B over 2A. And so we can do X equals negative, so B is negative 6, so negative B is 6 over 2 times 2, which is 4, so 6/4, so 3/2. Okay, we know the vertex occurs at X equals 3/2. Let's find what that actually is. So we're going to take X equals 3/2, plug it in here. So F of 3/2 equals 2 3/2 squared. We're just plugging this all in. Minus 6 times 3/2 plus 3. Okay, just some arithmetic to do. So this is 9/4 times 2 is 18/4, which is 9/2, minus 18/2, or 18 over 2, plus 3. I need a common denominator, so I'm going to write plus 6 over 2. So let's see if I can do this right. 9 minus 18 is negative 9, plus 6 is negative 3, so negative 3 over 2. Okay, so that's the Y coordinate of the vertex. I'm just going to make a really simple, quick graph of this so we can kind of see what the deal is here. There's an XY axis or coordinate plane. We have the point X is 3/2, Y is negative 3/2, so somewhere over there. And then since this is positive, if we graph it, it's going to go up somewhere like this. And this is obviously super rough. Okay, so let's get back to our domain and range question here. Domain, what can X be? What can we input into this function? Is there anything we can't put in for X? No, we can put in whatever we want. Positive, negative, 0, huge number, small number. So we're just going to write X is an element of the real numbers. X can be any real number, and that's fine. Okay, the range, and so I'll just put domain here to remind us, the range is a little bit different. Can we get literally any number in the world for Y? Well, no, because remember that the vertex of a parabola always represents a minimum or a maximum value of that function. In this case, it's a minimum value of negative 3/2. There are no points where we can get a value of this function that's less than 3/2. The only thing we can get is either negative 3/2 or something higher this way or something higher this way. So our range, so one way we could write it is Y has to be greater than or equal to negative 3/2. Let me get that right there. Another thing we could do is we could write each of these using interval notation. And of course, on a test or in a homework, I'll be clear about which one I want you to use. Let's start with the domain. Well, all real numbers just means everything from negative infinity all the way up through infinity. So we could say X is an element of this set here, everything from negative infinity to infinity. The range, well, we can kind of see it this way. Like it doesn't start at negative infinity. It doesn't start until negative 3/2. It does include that, so that's brackets. Y can be as high as we want. We can get super huge outputs for Y, but negative 3/2 is a minimum. So from negative 3/2 all the way up to infinity. So most likely on a test for now, this is how I would have you write it in interval notation. That's a basic introduction to domain and range. And if you're just graphing a quadratic function that's just sort of hanging out by itself like this is pretty much what's going to happen. The domain will be all real numbers. The range, it'll either be from the minimum, the Y value at the vertex going up, or if it's like this, then the range will be from the maximum value, the y value at the vertex, going down. Incidentally, if you got that, let's just say this was y equals 2. Just to do a reminder on interval notation, this would be something like starting at negative infinity all the way up to 2. Okay, so that's kind of a standard one. Let's go to a situation where we have a word problem. So there's a little bit of real world context, and I'll give you a moment to read this one. Okay, this one isn't looking for the maximum height, but we do need to know how long this cannonball is in the air. So we've had some questions like this. To find out when it stops flying, we want to find out when it hits the ground, when the height is 0. So I plug in 0 for the height equals negative 16t squared plus 80t. Okay, equal to 0. First thing is greatest common factor. That would be t minus 5. Set each of those equal to 0. So either t equals 0 or t equals 5. So this means that it's at height equals 0. It's at a height of 0 at time of 0, of course, right, when it gets launched. Then it's up in the air for a while. And then it returns to the ground, a height of 0, after 5 seconds. So in total, this is in the air for 5 seconds. Let's look now at domain and range. In this case, we have height as a function of or based on time. So time is the input. This is kind of like the x. And height is the output. We can see that here. That's kind of like y. If this question asks for domain, we're talking about time because that's the input. So let's start with that one, domain. Well, this isn't all real numbers because this equation, this function, it's only valid for the time when the cannonball is actually flying. Like we can't have negative time. It's not valid at negative 8 seconds. It's also not valid anymore after the cannonball hits the ground. It's just stopped at that point. So it's also not valid at any point after 5 seconds. This equation, this function is only valid from t equals 0 to t equals 5 while the cannonball is flying. So for this one, we would write t is an element of just this small set, starting at 0, ending at 5, nothing else. Okay, so that's how we would write the domain. As far as the range, so now we're talking about the height. What are all of the heights that are possible? Well, okay, clearly the lowest the height can be is 0. What's the highest that the height can be? Oh, well, now we actually do need to find the maximum. So I'm gonna go back here. We know now how to find the maximum. We use x equals negative b over 2a to find where that's gonna happen. So that's negative 80 over 2 times negative 16. I just know this is going to reduce to 2.5. Yes, it's halfway in between those. That's not a coincidence, but we just want to practice with negative b over 2a. Okay, by the way, I made a quick mistake here. This should not be x. We're not dealing with x, we're dealing with t. Okay. So the maximum height occurs at t equals 2.5. Let's find what that maximum height is. So the height at, the height at 2.5 is negative 16 2.5 squared plus 80 times 2.5. Okay, let's figure out what that is. And some arithmetic gives us 100, and yeah, that'd probably be a calculator one. Okay, this is the maximum height. So we know the minimum height is 0, the maximum height's 100. And so we can write that as our range. Now we're talking about h. So h is an element of this little set that the lowest it can be is 0, the highest it can be is 100. Because again, this equation is only valid from t equals 0 to t equals 5. And during that time, the only heights that this cannonball is at are between 0 and 100. So in summary, what to take from this? First, for just a quadratic sitting by itself without context, usually the domain will be all real numbers. The range will be either from a minimum point going up or from a maximum point going down. But if you get something like a word problem where there's real context to it, you actually kind of need to think about, like, when is this actually valid? And that's what we had here. It's only valid between t equals 0 and 5. And during that time, we only have heights between 0 and 100.